In this video, we're going to talk about something called effect size. And up until this point in hypothesis testing, we've been talking about statistical significance. We're talking about the probability of finding our sample mean given the null hypothesis being true. And when we do this hypothesis testing, we can talk about whether something is statistically significant. But that's only one side of the coin. The other side of the coin is something called effect size, and we're going to talk about that next. So in this section, we're going to compare and contrast statistical significance with something called practical significance. I'll explain what is meant by effect size, and we're going to use something called Cohen's d to calculate effect size. So statistical significance, we've been talking about this. Results are unlikely or there's a low probability, and that means we have statistical significance. Our test statistic is in that critical region, and we can reject the null and say that something is statistically significant. But statistical significance really doesn't tell us about whether the results are meaningful in a practical sense. Yes, we can say that finding our mean is unlikely, but what does that really mean? That's where effect size comes in. We call effect size practical significance. Practical significance is just a question of, so if there's a difference, is it a big difference? Does it really matter? So effect size is a measure of magnitude. It's a measure of the size of the treatment effect. Sometimes we have large treatment effects. We can really see differences, and sometimes we have small treatment effects. And Cohen's d helps us calculate these. So Cohen's d is the most commonly used measure of effect size. We call it a standardized measure of the mean difference because it is independent of sample size. If you look at the formula on the right for Cohen's d, it's basically a ratio of the mean difference between the population mean and the sample mean and the standard deviation. So this is very similar to the formula that we've used before, where the mean difference is what we're seeing in our data, and the standard deviation is sort of the typical, what we would expect. Mean difference, that's the data we collect, and the standard deviation is what we would expect. So when we're interpreting Cohen's d, we say that if Cohen's d is at 0.2, it has a small effect. Around 0.5, we call it a medium effect, and 0.8, we call it a large effect. And of course, in our research, we want larger effects. So let's take a look at our research study that we've been talking about. If we take our mean on the Wisconsin card sort of 92 for the people who ate blueberries for 6 months and subtract the population mean of 80, that gives us a mean difference of 12. Now we take that 12 and we divide it by the standard deviation. That's the variation that you would expect to see. 12 divided by 20 gives us a Cohen's d of 0.6. And so therefore, our research study, where people had a daily dose of blueberries over 6 months, had a moderate effect on cognition, or medium effect, for the sample of adults over age 65. So this is the way that we gauge sort of the practical significance. Yeah, I guess that kind of means something. That's enough of a boost in cognition that it would make me want to eat blueberries. Now, if I had a Cohen's d of 0.1, that would be a really small effect size, and then I'd start to think to myself, well, maybe it really doesn't mean anything. It's statistically significant, but doesn't really make that much of a difference in my cognition. So effect size measures the practical significance of our results. So just keep in mind that hypothesis testing helps us determine whether results are statistically significant. We've talked about that. Is there a difference? Are our results extreme? Are they statistically significant? We use probability to figure that out. But hypothesis testing tells us nothing about whether our results really mean anything, if they're substantial or big. So it doesn't really talk much about the real impact of the independent variable on the dependent variable, but effect size will tell us about the magnitude of the result. So in our next video, we're going to walk through an example using some new data. I'll see you there.